Greetings class. So today we are going further into the topic of resistance. So we are dealing with energy and change. So last time we met, there was explanation on what resistance is and what electricity is and how resistance helps us during electrical changes. So now I would like us to start with some terms and then we'll get into a demonstration for us to actually understand better the concept of resistance in electricity. So as we know, resistance is the opposition of electric current in a circuit. So a resistor in an electric circuit, it helps in inhibiting too much current flow in a circuit. So if a circuit has too much electricity or too much current and voltage flowing through it, it may burn up the circuit, resulting in a fire or in a damage in the circuit. So there are a few terms I would like us to go through before we get into the demonstration of resistance, and we're going to look at an example of a resistor operating in an electric appliance. So the first term I like us to look at is electric current. So electric current is measured in amperes. So it is actually a component in an electric circuit. It is a variable in electricity. So electric current is the flow of charges, electrons, electricity electrons flowing in a circuit. So that is electric current. And then we have conductors. What are conductors? Conductors are objects that allow the flow of current in the circuit. So let's say we have a metal, which I have right here. This is a metal chain. If this metal chain was in contact with electricity, and you would be in contact with the chain at the same time the electricity is flowing through the chain, you will actually feel the electric current because you get shocked by the electric flow in the chain, because this is a metal chain. Metals are very good, if not the best conductors of electricity that we have. So that was one example of a good conductors. Good conductors, they offer very low resistance when it comes to circuits and electricity. So other good conductors are silver, we have copper, we have gold. All of these are good electric conductors. So we also have temporary conductors like silicon. Silicon is a temporary conductor because it conducts electricity under certain circumstances, like maybe under a certain type of heat, or maybe under a certain amount of pressure, or maybe like it depends on how small or long the silicon is. So due to this, the silicon is called what? A semiconductor. We understand why it's called a semiconductor, because sometimes it conducts electricity and under other circumstances it does not conduct electricity. So we get that. So we have our insulators. Insulators are actually objects that do not allow for the flow of charge in an electric circuit. So insulators, let's say we have I have a brush here with me. A brush, it is made out of plastic, and it is made out of these are hairs we use to brush our hair. So these hairs are the actual brush. It is insulated, and the plastic is an insulator. So if you were to put electric contacts in this plastic, there will be, and then you would hold the brush, you would not feel anything, because there is very high resistance and there is no effect of electric charge. All right. So let's look at electricity. Let's look at the resistance. There's wood, there's rubber, and other non-conductors like wool, cotton, we have leather. All of these materials are insulators, which means they do not conduct electricity. So in a circuit, resistance that we were talking about in our first lesson. So in my notes here, it states that the longer the resistor is connected in electric circuits, the higher the resistance. So if you were to have a resistor that is very long, so there is very high resistance, because it occupies a longer space throughout the circuit. So it will take the electric charge longer time to pass through the resistor, losing amperes along the way, and then the resistance will be higher than the electric current. So the longer the resistor, the higher the resistance in the circuit. So the thicker the resistance, the conductor, the lower the resistance. If you had like a metal piece that is very thick, very dense in a circuit, there is very low resistance, because the conductor occupies more of the space than the resistor. So the more of the conductor there is in the circuit, the more there is resistance. So let's say, for example, like you have two hose pipes. You have two hose pipes, and then you have a thick hose pipe and then a thin hose pipe. So in a thicker pipe, it has like a bigger hole that the water will go through. So there is very low pressure, and then there is low resistance, or the water will flow freely. But in a very thin hose pipe, you can tell that the pressure of the water becomes much more greater than the pressure that is in the thicker hose pipe, because there is much smaller space. So we can compare the resistance to the thickness of the hose pipe. I hope we understand so far. So resistance, it varies in temperature. Like for metals, the resistance increases when the temperature increases. Okay, and then the temperature decreases, also the resistance it decreases. So we can say that resistance and heat is directly proportional, because as the other one increases, so the other one does that as well. So for my demonstration on resistance, here we have a laptop charger. I like to use a laptop charger because it has this space right here. It has this part right here. This part, so here it's a normal wall plug. So you plug this into a power station, and then the charger is in the end. This is the charger itself, where you connect it to the laptop to charge it. So this space right here, this part right here, it contains a very great resistance, because as electricity comes from the head as electricity comes from the head to all the way to the charger, there is a resistance here preventing too much of the electricity from flowing through the charger, because chargers are very sensitive. Chargers are very sensitive in nature, so they need a very high resistance so that they will operate well, so that they will not short circuit, they will not overheat, they will not get damaged. So this is our demonstration of actual resistance working in our appliances. So I hope there are many other examples that we are still going to do along our path in completing the resistance, the topic of resistance. As we get into, I think next week we will be doing other parts of the circuits, like we'll be doing current, we'll be doing voltage, we'll be doing the types, the components. So we'll be doing many things next week. I hope today's lesson was very productive, and I will be providing I think a small activity after the class to consolidate our lesson. So I am very happy and to work with you. You've been a very great class. I will see you next week.